Hello and welcome back to the lab. Today on the bench we have the FG506 again. I still have this for a little bit in the lab. If you haven't seen the previous video on this unit, check it out. This is an update video and also something that I've been kicking around and thinking about while I have it here in the lab. This unit does need to go back to its owner. I do not own it, and for those who are finding this video first, check out the previous video on this unit for a little bit of repair. At the end of that video, it was still giving me a little bit of trouble. I did get the blessing of the unit's owner to replace the TI socket that was giving me some trouble. Actually, it's right here. And I have a long form video on these specific TI sockets and why these are terrible. But that was interfering with an op amp that's right about here. Actually, let me just move the camera. This op amp right here is the one that was arguing with me and giving me such a hard time. But the unit is now up and running again. And for a real quick recap, this particular unit is an engineering sample. This one's actually engineering sample 4. Only 6 of these were made. This was the prototype of a product that never was, and unfortunately didn't make it into production and out into the wild. So really fortunate to have this in the lab to take a look at it and go from there. What the design case for this particular module was for testing audio amplifiers. We have a sweep set by this top, the start of it is set by the top knob. I have it all the way down. The bottom knob sets the stop frequency. I have it all the way up. And I have the 10x pushed in on the top and the 100x pushed in at the bottom. Actually, we can slow this down a little bit more. I don't want to touch this because these buttons are susceptible to finger oils. But if we pop it out, we now have a 1x. So we have 1x at the bottom, 1000x at the top. It doesn't like 1x, that's for sure. Okay, what happened? Okay, after a touch more switch cleaning, we have sweeps again. So we'll turn on the sweep. So at the low end, we can see the scope over here. It's sweeping right about 7.5 hertz. We'll kick this up, and it'll speed up significantly. Now we're sweeping right around 100, or we're not sweeping, but we're oscillating at 129 hertz, or sorry, 129 kilohertz. So we've got a start waveform at 7 hertz. We have a stop waveform at 130 hertz, and we'll speed this up a little bit. Actually, we'll slow this down so we see the whole thing. And I'll enable the sweep, and then I'll zoom in on the scope. So we'll turn the sweep on. And the scope's kind of going nuts. But what we'll do, and this is really going to stretch this scope quite a bit, because what we're doing is we're sweeping from 7 hertz to 130 kilohertz over the course of about 5 to 10 seconds. So an incredible sweep range. Okay, one other thing to know about the sweep from this function generator is the sweep is logarithmic. So it's spending the same amount of time in each decade. So even though the sweeping speed is logarithmic, the frequency transition is linear. So given that I have to send this back to its owner, and it is a rarefied piece of equipment, I wanted to see if I could duplicate its functionality here in the lab. We have a whole bunch, almost a wall of HP function generators, things like that. So lots of things from many different eras, as well as some modern stuff. So what we're going to do is we're going to see if we can duplicate this waveform and duplicate the functionality of this FG506, and we're going to take a look at all of the sine wave generators in the lab, and we're going to talk about whether they will or won't do what we're looking for. First up on the list is these guys. So I've got 3 over here, 1 here, and 1 here. None of these are going to do what we're looking for out of the lab, as these are fixed frequency sine wave generators. Incredibly low distortions on the SG505. The SG502 is a low distortion. The 505s are ultra low distortion. The HP200 CD is a wideband, but they're all non-sweeping. They all just kind of sit, and you can sweep them manually with the dial, but that's about it. Okay, over here we have a couple more function generators and 1 more signal generator. The difference being FGs for function, SG for signal. This is another SG502. Not going to be able to do what we're looking for. The FG501A doesn't sweep. It's a function generator, but it's a fixed frequency function generator where you can move it, but it doesn't do any sweeping. The FG507, we finally get sweeping functionality. However, if we look at the front panel here, it's not even going to work. I don't even have it powered on because it's not even worth testing, at least in this conversation. It's a great function generator, but it only sweeps in 1 decade. So I can set the decade, I can set the sweep time, but I can't have it sweep. There's no setting the stop decade for this one. So where I could set the multiplier on this one to 1, I could then sweep from 0.2 to 20, so 200 kilohertz to 20, 0.2 hertz to 20 hertz, but I can't finish the sweep at a higher decade, so that one's going to be out as well. All right, coming over to the HP side of things, we're starting to get sweep functionality. I've already set up the sweep on this one, haven't tested it yet, but we'll set up the sweep on this particular unit. Actually, we want to slow this down, so can this go down far enough? Start sweep is going to be 1 hertz. No, it errors out. So it can't sweep from 1 hertz to even 50 kilohertz. Start sweep 100 hertz. So I can do 100 hertz to 50 kilohertz, but I can't do 1 hertz. So we do have a sweep limitation there. Let's try 10 hertz. Nope. So start sweep 100 hertz. And so we'll test this one, see what it looks like. We'll set this guy up. So we'll do a start frequency of 1 hertz. Stop frequency of 100 kilohertz. 1 hertz, 100 kilohertz. We will do a sweep time of 5 seconds, just because we can. On this particular unit, our sweep time is not nearly as variable. We have 01, 0.1, 1, 10, 100, and 1,000 seconds. So, and that's seconds per decade. So we'll see how that one goes. So we got this one set up. So let's check and see what we get out of these 2 units. Keeping in mind, this one is newer than that one. Okay, so here's our sweep result. We've also set it to a logarithmic sweep. And I see some stuff that I kind of don't like already. But what we're going to do is we're going to increase the sweep time. Time is going to go to 10 seconds. We'll slow this down. So one of the things we'll notice is as it comes in, you see the jumps in the waveform where as it's going up through decades, it's pulsing. There, it was really visible. So what's happening is the frequency's contracting and it's kind of jumping. It's not a smooth transition up to the top end frequency. If I switch this to linear, The jumping will go away. I still see a little bit of an artifact when it's changing decades, but not as smooth as the tech unit. Next up, we'll try the 8165. Turn it 10 seconds per decade. It's going to slow it way down, but we'll get a chance to see it. One of the things I couldn't find was I could not find anything on how to put this into a a logarithmic sweep state. So we do have sweeping on the 8165, and it's pretty stable. It's coming in smooth. Everything's looking good. Don't have near the frequency range that we were looking for. The frequency counter is telling us it is getting down to 100, and it is getting up to 50 kilohertz, but we could not do what's essentially 1 hertz to 100 kilohertz in a logarithmic sweep with a blanked return. So not having the blanked return, we're seeing it come in, and then we're also seeing it go back out. Come in, and then go back out. The blanked return is it'll sweep low to high, blank, jump back over, sweep low to high, blank, jump back over. That's essentially what the difference is. All depends on what you're trying to look at. Due to if you're trying to draw a bode plot on a scope or something like that, you'd actually a good way to do this these days would be fire it off on a single shot on a digital, have it sweep once, and then ignore the rest of it. But it would mess with because the scope sweep goes this way, but if the amplifier sweep is going that way, it can mess with the bode plot a little bit sometimes. So the 8165 kind of works. Let's check the 8904. The 8904 was quite interesting to set up to get it to do the sweeping function. It was able to do the sweeping function. I believe all of them should. We'll zoom in on this one and I'll show you what I mean. So essentially I have channel A. Actually, we'll start at 1 hertz. We'll see if it'll go down that low. We have an amplitude of 2 volts. Waveform is sine, 0 degrees of phase, and destination's out 1, which is where we're hooked up. No problem. What you have to do is feed channel B to the destination of FM to get this to work right. So you have channel B, amplitude is 100 kilohertz, and our frequency is 0.1 hertz. That's the speed of the entire sweep. If we slowed it down some more, the sweep will go a little bit slower. But essentially, what we're doing is we're using channel B and the FM modulation to modulate channel A on the output of this unit. That gives us a waveform that is also not return blanked, but is a ramped waveform, which actually looks a bit more sinusoidal. But if I turn the waveform into a sine wave, it's just going to oscillate a little quicker with that sine wave. So that's the sine wave. That's the ramp. Not sure which one I like better on that one, but that's what we get out of the 8904. So the 8904, with all its complexity and all its power, also has a hard time meeting the spec of the FG506, or meeting the function of the FG506, I should say. Okay, let's set up the big one. We're going to do start frequency of 1 hertz, stop frequency 100 kilohertz. Amplitude is going to be 2 volts. I am also properly terminating this into 50 ohms. Sweep time is going to be 10 seconds because we can, and this is probably not going to be 10 seconds per decade. It's probably going to be 10 seconds for the entire sweep. Where's my seconds button? Seconds. And to get sweep, we just hit continuous, and now we have a sweep. So let's take a look. And here we go. Clearly that needs to... Oh no, it's not 2 volts peak to peak, that's 2 volts RMS. Amplitude, 2 volts peak to peak. There we go, that's better. I was going to say, amplitude was way too high. So we have a sweep function on this unit, and this is actually doing the blanking a lot more than more like I'd expect. This is a HP 3326. It's really rapidly, so it's ramping slowly as the frequency comes up, and then it's really rapidly going back to the other end. So it's a true ramp as opposed to a kind of triangle-ish drift up, drift down. So the 3326 has done the best job so far. However, it's not a logarithmic sweep. So as we get higher in frequency, it's starting to go a little slower. So still not quite able to, the best one yet, but not quite able to meet what the FG 506 actually does. All right, let's check out some of the ultra modern. These were purchased new in the lab for a different video about calibrating a oscilloscope with a function generator. Can you do it with a modern one? So we have a Rigol 2102 and a 4162. So we have 100 megahertz on the 2102. That's actually the top of the line of the 2000 series. They don't get faster than that. They top out at 100 megahertz. This is 160 megahertz on the 4000 series. The one below it is the 4102, which is the 100 megahertz. So let's take a look if we can set these up to get the same waveform that this is able to produce. So we want our center to be 50 kilohertz. And we want our span to be 100 kilohertz. And that's close enough. It errored out. It can't go all the way to 0. So it's starting at 1 and it's ending at 99, something like that. So the span is 99. 9999998. So I'm off by 2 hertz. So this might be able to do it. That's not too bad. Let's pop a signal in. And here's what we're getting on the scope. Now this is acting a little funny because of how the trigger's working. So in the beginning, you're going to see it start to move. And now it's going to trigger, and then it's going to act a little weird, and it's going to come up. So we are getting linear sweeping, or I should say we are getting logarithmic sweeping. Everything is looking good. So it looks like the DG 2102 can give me a similar waveform. To trigger this a little bit better, I did set the trigger to DC because we are starting at a very slow speed. When you see the wave wiggle like this on the scope, it's actually because it hasn't triggered yet. It's not fast enough for the scope to say, hey, I got something. And we can prove this by doing a normal mode trigger, and the waveform will go away, and now we'll just see it locked in, right, starting trigger, and then it goes. So that's really a trigger fault on the scope, or not a fault, but a triggering phenomenon with the 7603. Okay, on the DG4162, you actually have to set up 2 different parameters. So you have to set up the sine wave, where We will set, let's see here. We'll set the start to 1 hertz. All right, so we're sweeping 1 hertz to 100 kilohertz with a sweep time of 10 seconds to make it even. And also on this particular unit, you have to set up the sweep parameters, and then you have to set up the amplitude parameters in the sine function, and then you go into sweep and then enable the channel. So a little convoluted, but we have that in high Z, so I have to pull the 50 ohm terminator off. And then we will turn the output on and watch what happens. So we'll take a look here. We'll see some flickering, and then it comes in, and that is behaving exactly as I would expect it to. So of all my function generators here in the lab, to duplicate the functionality of the FG506, it looks like the DG4162 does it the best. Which I should hope it does. It's a pretty high-end function generator. So I can get the functionality back here in the lab if I need it, and everything's good to go. Now, let's talk about the box that I'll use if I ever need to do this kind of testing. So for setting up and doing amp response plots and a couple of other things here in the lab, we would take a look at, use the Quantasylum box. I had to pick up this audio analyzer for measuring the distortion outputs on some SG505s and SG504s. Sorry, SG502s on SG505s. And this actually needs a computer to be hooked up to it, which we do have available. But this particular unit is a audio spectrum analyzer, so it does all the bode plotting, things like that I could ever want out of this, so I don't need to worry about hooking up a signal source to another scope to do it. It just simplifies the measurements because I can just measure direct. And I don't have to worry about the persistence of a CRT at incredibly low frequencies. That's something where a digital scope actually outperforms a analog scope in 2 places: the extremely fast signals and the extremely slow signals. I would much rather look at 5 hertz and sub 5 hertz signals on a digital scope where it can store up a waveform and I can take a look at it versus a analog scope where I'm trying to follow around a wandering dot on the screen and take some measurements. So we've definitely come a long way in terms of capabilities and things like that. Take a look at the QA403 audio analyzer. Has some incredible distortion specs for the price point, and also for to see it in action, take a look at my SG505 video where we direct measure the distortion of an SG505 on the Quantasylum, made testing and validating my SG505s so much easier. So how did the Tech FG506 stack up to equipment today? Well, specifically for audio work, the Quantasylum rings in the middle 3 figures. Not the cheapest box on the planet, but for its specs, it's at an absolutely incredible price point. In terms of function generators, though, you need to hit the you need to add a digit to that and go into the 4 figures on function generators to get into similar performance to this particular unit that unfortunately did not end up making it into production. Testing it with all the other HPs that I have, those were very expensive function generators in their day, and still are. In the 1990s catalog from HP, the 3326, which actually does not have logarithmic sweep, it only has linear sweep, so says the catalog, had a catalog price of $10,000 in 1990s money. So I didn't realize that thing was that expensive. So pretty incredible what this little FG506 can do. And Kind of bummed they didn't make more. But sometimes that's the way it is. So thanks for stopping by the lab and taking a closer look at this FG506. And we get to play around with it a little bit more before we have to send it back to its owner. If you like what you're seeing, hit all the YouTube buttons, like, subscribe, and bell. If you'd like to check out a little bit more content, check out the Patreon page. They're running ahead on video releases for YouTube, and their support helps bring videos to YouTube and keeps the lights on here in the lab. I'm eternally grateful for all the support from the patrons, and they do, very much so, more than anybody knows, helps me bring videos to YouTube. So for that, thank you, and as always, more's on the way, and I will see everybody in the next video. Bye for now.